we're going to build a PetaLinux project that's tailored to our Arty base design. So in order to run PetaLinux, one of the requirements is that the microblaze needs to use a specific configuration. So if we double click on the microblaze block, we'll be able to make that. So if we go select configuration, we need to use Linux with MMU or low-end Linux with MMU. So I've made that change. As for the other requirements, we need a UART IP with interrupt connected. We've got that. We need Ethernet with interrupt connected. We've got that. We also need an AXI quad SPI with interrupt connected, and we've got that. So we've done everything, but there is one other thing that would be nice to add, and that is to connect the interrupts of the GPIO IP. So I'm just going into each GPIO block now. I'm enabling the interrupt, and then I'm going to route it through to our interrupt concat. So I have to also reconfigure my interrupt concat as well so that it includes 2 more ports. So I'll make that 6 ports. So now that I've changed my block design, I have to save it first. And then after saving the block design, obviously I'm going to have to regenerate a new bit stream. And then once the bit stream is generated, I want to export the hardware because I'm going to use that to generate PetaLinux. So now we've switched over to the Linux machine here. I've copied the entire Vivado project Arty_base over to a working directory called Arty on the Linux machine. As you can see, the Vivado project was exported into the .sdk directory. And in the previous video, we created some SDK applications that we can also find in there. So the first thing we have to do is to launch the PetaLinux tools. And to do that, we source the settings.sh script on the PetaLinux install path. So then we want to cd into our working directory, which I called Arty. So now we can create our PetaLinux project by typing petalinux-create type project template microblaze name Arty_PetaLinux. That's specifying the microblaze template for this project and calling the project Arty_PetaLinux. So when we run that, you'll see that PetaLinux Tools has created a directory called Arty_PetaLinux. Now that's going to contain all of our PetaLinux project files. So we cd to that directory, and now we're going to import the exported hardware description. So we type PetaLinux config get hardware description. We specify the .sdk directory from the Vivado project as our hardware description, and we use the old config parameter as well to say that we don't want to open the menu. Normally when you run this command, it would give you a menu which allows you to change some of the configuration of the project. So that'll take some time. Okay, so now this is the time where if you wanted to, you could configure the kernel. So that is to enable certain drivers and other configurations of the kernel. If you want to do that, you can do it here by typing petalinux config-c kernel. The other thing you might want to do is configure the root file system. So anything you want to include in the root file system, you can do it now. And then after those are done, we run PetaLinux build. But before we do that, actually, we have to make a modification to the device tree. So to make additions to the device tree, we've got to modify a specific file located in project spec meta user recipes BSP device tree files. The file name is systemuser.dtsi. Now the PetaLinux tools will automatically generate a device tree based on our exported Vivado design. What this file is for is to allow you to make additions to the automatically generated device tree. We want to add the PHY address to the device tree so that the Ethernet driver can communicate with the PHY. So I'm just going to open it in Sublime Text Editor, and I'm going to just copy in our additional code to the bottom of the file. You'll see that we also set the MAC address here, but it's not really that important. The most important thing that we do here is specify the PHY address of 1, because without it, the Ethernet driver would not be able to communicate with the PHY, and we would not be able to get a network connectivity. So that's done. I've saved the file. Now we can move on. So we build PetaLinux by typing PetaLinux-build. So building PetaLinux takes a bit of time. So now what I'm going to do is plug the Arty to my Linux machine with a USB cable. So that gives me JTAG and UART access. I'm going to also connect the Arty through with the Ethernet cable through my router. The router is running DHCP, so it should get assigned an IP address automatically. So now I'm going to run PuTTY, the UART console. Now I'm going to use a speed of 9600. Now we have to program the FPGA with the bit stream. That's PetaLinux boot-jtag-fpga. So that's command to program the bit stream. And when that's done, now we can program the FPGA with the Linux kernel. So we run PetaLinux boot-jtag-kernel. That's to load the kernel. Now the kernel takes quite a lot of time to load, quite a few minutes, but it's been I've sped it up here so you don't have to wait. Then once the kernel is loaded, it will obviously boot PetaLinux. That's what we see here. It's booting up. And when it finishes booting, I get the login prompt. My login name is root and the password is also root. And then once we're logged in, the first thing I want to do is check my IP configuration. I want to make sure, I want to find out what the IP address is of my Ethernet port. So I can see that the Ethernet port's been given the address 192.168.2.19. So I just now want to try to ping that from the Linux machine. So I'm in my Linux command terminal here. So I'm going to ping the Arty from it. Now I've just made a mistake with the IP address. So if I try and do it again, and this time use the right IP address, then it works.